Hello and welcome to Implementing Graph Algorithms in Scala by Pact Publishing. My name is James Kotayer. I'm a software developer and a Scala trainer with interests in scalable high-performance programming and algorithm design. What is the quickest way for you to learn a new programming language or technology? One good way is to pick specific well-known problems and discover the tools available in the technology you want to learn about. You then use these tools to build the experience while solving the various problems. This is learning by example. In this course, we'll do exactly that. The course is designed so in each section we pick one well-defined problem. We then walk through the solution using the various functional tools available in Scala. Along the way, you will experience and learn these new concepts and tools. In this course, we focus on problems that are solved by graph algorithms. We start the course by introducing what it means to be functional and which principles we should follow while developing in Scala. In the first section, we will look at how we can represent graphs in a functional manner by following these principles. We do this by first explaining how the representations work, and then we step through the Scala implementation. In section 2, we will look at graph traversal. We will learn about two types of graph traversals. We demonstrate both types by examples and then show step-by-step functional implementations. In the third section, we look at topological sorting. In this section, we first demonstrate the applications of topological sorting and present and implement various algorithms that achieve this. Each algorithm is carefully explained using step-by-step examples. The next section is about cycle detection. Here, we describe various practical examples of this problem, then show how we can solve this by various algorithms, each time showing implementations in Scala. The next section, we talk about shortest paths. We describe applications and show how the shortest path algorithm works. Later, we implement the algorithm in Scala. In the final section, we pick a slightly more challenging problem. In this section, we look into finding the maximum flow in a flow network. As usual, we present applications, algorithms, and implementations. For this course, it's enough if you have a Mac, Linux, or a Windows operating system, with an IDE such as IntelliJ or Eclipse installed. Ideally, you have some basic or beginner knowledge of Scala, as it will help you understand some concepts quicker. If you don't know anything about Scala, knowing some basics about another functional language should also be enough. As a rough benchmark, this course is for you if you know how to perform a fold left. The target audience for this course are developers who want to experience functional programming and learn Scala by example. It's also ideal for developers who want to do a refresher about graph algorithms and learn how these are implemented functionally. By the end of the course, you will have learned about principles of functional programming and discovered more advanced features in Scala. Of course, you won't be an expert. However, you will have the knowledge and tools to develop more advanced functional software. You will also have experienced various interesting algorithms and learn how they work. These will come in handy in your next coding interview. So with this in mind, let's get started and learn more about functional graphs in Scala.